Will Star Trek and Star Wars finally become a reality? Now, amazing concepts and incredible technology are emerging. It's the final frontier. Here are top 5 technologies that could take us to the next level. Number 5. Science fiction to reality? You've probably heard of antimatter. This has the potential for a super efficient and powerful fuel source. When antimatter and matter combine, they annihilate each other and release a huge amount of energy in the form of gamma-ray photons. This energy has great potential to power a spacecraft. So how would an antimatter propulsion system work? Well, antimatter would need to be produced and contained first. Not such an easy task though, because antimatter is unstable. Plus, it requires a lot of energy to produce, unless we can figure out how to harvest it from our atmosphere. It needs a special containment system, such as a magnetic bottle called a minimum magnetic field trap. This prevents it from coming into contact with regular matter. One use would be to inject it into a propulsion system, such as a rocket engine. Once antimatter combines with matter, they release a large amount of energy which is used to heat and expand a gas such as hydrogen or argon. This is discharged out of the back of the rocket, propelling it forward. However, unlike most science fiction applications, you wouldn't actually use the antimatter as a power source. You would instead use the byproducts of matter-antimatter annihilation in order to drive a ship. As an example, consider an antimatter sail. A sail is made of 2 layers, carbon fiber and a uranium-238 coating for fuel. The sail actually uses fission to move instead of the matter-antimatter annihilation. When the antimatter comes into contact with the uranium foil, fission occurs. This produces 2 fragments, both of which have a velocity of 13.9 million meters per second, or 13.9 thousand kilometers per second, which gives it a specific impulse of 1.4 million seconds. Far better than any propulsion system we have today. So you're using incredibly fast particles generated by the matter-antimatter annihilation in order to generate velocity or momentum. It's revolutionary! Will this allow us to travel to other planets and other star systems? What do you think? Number 4. Chances are you've never heard of solar sails. It's a form of propulsion that uses the radiation pressure of sunlight to push a spacecraft through space. Made of a thin reflective material, they stretch out into a large flat surface. When sunlight hits the sail, it bounces off and pushes the sail in the opposite direction, providing a small, constant acceleration. Solar sails may not be as sexy as other space tech, but they have important advantages. One is no onboard fuel required, which is highly conducive to long space flights. Also, they can reach very high speeds, potentially enabling interstellar travel. With current technology, it would take over 6,000 years to reach Alpha Centauri, the nearest star to us. If solar sail technology is perfected, it could cut the trip to 20 years. But is it viable? You decide. LightSail 1 was sent into Earth's orbit in 2015, followed by LightSail 2 in 2019. According to Professor David Spencer from Purdue University, LightSail 2 is the first solar sail mission that can reorient itself relative to the Sun and control its orbital energy. While it's a small project, it's sponsored by the Planetary Society, among other organizations involved. The satellite has to perform 2 maneuvers each orbit, which is basically a turn, so that when it's moving towards the Sun, it's angled so the Sun isn't pushing it. Then, when moving away from the Sun, it's showing as much area as possible to the Sun to maximize thrust. It harks back to Carl Sagan, one of the initial founders of the Planetary Society. This rudimentary model travels on the radiation and particles of solar wind from the Sun. Why a solar sail? Perhaps the biggest advantage is the Sun is always shining, supplying an endless means of thrust. However, initial acceleration is very slow, but over time it will increase to high velocity. Eventually, newer advancements could remedy this. With NASA's ACS-3 mission due to launch this year, like LightSail 1 and 2, this could be a next level for space travel. Number 3. This one seems promising, but is it? Nuclear fusion is the process of combining atomic nuclei and releasing huge amounts of energy. In December of 2022, for the first time, scientists produced a nuclear fusion reaction that created more energy than was expended. It's a breakthrough, tapping into the same kind of energy that powers the sun and the stars, said researchers at the Lawrence Livermore National Laboratory. While one step closer to fusion-propelled space travel, there are still obstacles to overcome. Temperatures from the reaction can reach over 100 million degrees Celsius. In order to contain it, we need a fusion reactor. However, we'd need to downscale the current technology for space travel. Among the different designs for fusion reactors, one promising concept is the tokamak, a donut-shaped chamber with powerful magnets on the inside. These magnets are used to confine the plasma in the center of the chamber and prevent it from touching the walls. Nuclear thermal propulsion uses heat created during fusion to expand and accelerate a propellant through an exhaust nozzle, creating thrust, propelling the spacecraft forward. Liquid hydrogen is pumped through the reactor core, which cools the core and passes the heat to the liquid hydrogen, which rapidly expands and accelerates out the thruster nozzle at high speeds. Typically around 8 kilometers per second, twice as fast as chemical combustion at around 887 seconds. There's still major challenges though. Liquid hydrogen must be stored at extremely low cryogenic temperatures, and we're still hauling fuel. Another possibility is using the reactor to power ion thrusters. However, we need some breakthroughs to achieve either. Oh, and to make sure there's no hydrogen explosion, be sure and slam the like and subscribe buttons. Number 2. This one is fascinating and already has a proof of concept prototype. It's called the Mega Drive, for Mach Effect Gravity Assist Drive. This propulsion concept utilizes the principle of the Mach effect. The Mega Drive uses small, high-energy vibrating piezoelectric crystals to create a bubble of energy around the spacecraft. By altering the properties of this bubble, the craft will be able to move in any direction, kind of like surfing on an energy bubble. Physicists Jim Woodward and Hal Fern developed the Mega Drive. It could potentially allow for speeds up to 1/10 of the speed of light, or about 30,000 kilometers per second. This could drastically cut travel time to other planets and star systems. Receiving 2 grants from NASA for development, this technology could open the entire galaxy to exploration, yet there are still challenges to overcome before the Mega Drive's travel ready. Perhaps it could be combined with the nuclear fusion reactor to vibrate the crystals? Exciting times! Number 1. Fascinating, Jim. Most have heard of the Star Trek warp drive. Science fiction has long inspired future inventions. This might just be the most amazing. Faster than light, the theory of a warp drive was first proposed by physicist Miguel Alcubierre in 1994, and it is based on the concept of warping the fabric of space-time in order to move a spacecraft through. The basic principle of Alcubierre's warp drive is this, that a space-time bubble is created around the spacecraft. It contracts in front of the spacecraft and expands behind it. This creates a wave that the spacecraft can ride, enabling it to move through space-time faster than light. A warp drive would require a huge amount of energy, and it would also require the manipulation of exotic matter. The concept of exotic matter is a hypothetical that has a negative energy density, which would be needed to create the necessary negative pressure to create the bubble. There are promising breakthroughs on warp bubbles. The most recent, however, is still in the lab theoretical stage, but promising to create a stable bubble of space-time without the need for exotic matter. That's exciting. However, obtaining the energy needed has not been cracked yet. These breakthroughs, however, open up new possibilities for development of warp drive. It's getting crazy, but only a matter of time before we are exploring the final frontier. There's a bright future ahead, especially if you watch another one of our videos.